everybody. We're happy to host a TIBCO Analytics meetup today on hurricane analytics. Thrilled to have the data science team at TIBCO and special guest Troy Roos from Roos AI, a partner company to TIBCO. This webinar is our contribution to R&D and the communities affected by the recent hurricane events. And we're hopeful that the data that we make available and the analytics that we make available to the community can help in additional R&D into these sorts of events. The usual disclaimers around some of the materials that are being presented. We will provide the slides and the data and the analytics on our community site. We'll give you details of that later on. Our group is active, folks who want to understand analytics, visual, predictive, geoanalytic applications across the TIBCO Spotfire stack. Welcome to join. Tell your friends, colleagues, come along. As I mentioned, this is a contribution we're making to the understanding of recent hurricanes, their attributes, effects, and aftermath. The data includes a lot of geo data as well as 311 calls. This is a joint effort with Roos AI. So I'll be giving a few introductory remarks. DJ is going to be doing a path analysis, Troy analysis of Hurricane Harvey, precipitation grids by Peter, and a wrap-up from Helene on the community. You'll see a place where you can submit your questions at any time by the Q&A option, and we'll answer those at the end, or we'll get back to you via email. We are going to feature a number of the geoanalytics capabilities of Spotfire, where you can bring in a base layer and configure that as to whether it's light or heavy. You can add markers to that, features on top of that, and then you can do calculations within layers or between layers using Spotfire, the TIBCO runtime for our engine. You can mix and match with Esri files in the layers, tile mapping service, web mapping service. You'll see those being featured. So without further ado, I'd like to hand off to DJ Rajdev, who's going to be speaking about the hurricane path analysis. She is going to cover four of the recent different hurricanes and show how to create a movie, extracting some data, doing the data prep, and some of the trends on stats analysis of these hurricanes. So DJ, I'm handing you the ball.
Thank you, Michael. Hi, everyone. So we're going to be looking at hurricane patterns, and the data that we've got is for about over the last 2 months. Before I start, I want to show you how to actually read the different things that will be going on. So what I'm going to represent is the cone of uncertainty. So at any point, the pointed end represents the current center of the hurricane, and the entire shaded region shows the probability of where the center of the hurricane can be with respect to certain time forecasts. For a lot of them, it's 5 days, but for a couple of hurricanes, it's 2 days. So be cautious of focusing on this end when you show it, but it's important to also see how the path went forward. Then we'll talk about the data briefly, but as far as the map is concerned, I have a TMS layer that gives me a cleaner background, but I've got a geometry column on top of it, which I wrangled from the data that I received. And for animation, I've used IronPython to actually move the trajectories. I've used IronPython script to go over the different timestamps of when the data was collected, and then JavaScript to trigger the filter operation every 1 second or so. So if I show you the actual data itself, there are 2 scripts that I wrote. One of them goes to the National Hurricane Center and constructs the URL for each hurricane archive based on hurricane ID, year, name, and ocean. Mostly we're looking at the Atlantic, I believe. So this is an example of how AL09 is Harvey. You can see it over here. So we get a lot of files, about 35 to 50 files per hurricane, and all of them are 10 to 15 KB each. Finally, what we've been able to do is embed a data function inside Spotfire that picks up these downloaded shape files. And we do the parsing, then we download the files, then we extract them into its individual components, which is points, lines, and polygons. I'm only using the polygons because those are the cones of uncertainty. Everything else becomes a little bit harder to track visually. So now when we pick up each of these polygon lines, I'm only extracting the column that I need and doing a handshake with geo properties that Spotfire understands so that it can just directly be put on a map as a feature layer. So we've eventually taken, I believe, 40 plus MB of data and converted it to less than 3 KB. The entire 3 MB, the entire file is about 7 MB for all the different plugins. So that was just on the data wrangling. We will be making this data available for you to use in your analysis on the community page. So moving on to trajectories. These are all the hurricanes shown together, and you can see the names and icons for all of them so that you're able to put a name on it in the legend. This is the timestamp of when the file was created. This timestamp just means that this is the time that the file was uploaded. The data that it has would essentially be a few hours before the timestamp and forecast for the next 3 to 5 days. So again, at every point, just focus on the pointed end and then look at the bulbous end. Let me start this. And you can see Harvey coming in. This is where it makes landfall and impact. And now it moves completely inward, and you can see Alma start to go over the Caribbean. And we've got actually 3 now. So we've got Jose, Katia, and Irma all swirling within the same region. So Katia did not measure high on the categories, but is still categorized as a hurricane on the National Hurricane Center website. Jose was moving away for a while, and then you can see that the probabilities, it starts to move closer to inward, but Maria comes in. And with Maria, you see a definite, the tail being dragged over Puerto Rico, and that is when a lot of the destruction took place. So this is from September 22, 23, 24, right up to the current day morning. You can see that now the head just stopped and receded away. So again, these are parts of all the hurricanes starting in mid-August and going until today morning. The other thing that I also wanted to talk about a little bit is the trend. So from these 5 hurricanes that were swirling over near North America's Mexico and Caribbean regions within the past 1 month, you can see that there's a definite anomaly within this month in the types of hurricanes and other climatic challenges that we've been facing. I wanted to point out an image from an article that was published at The Economist news report online. What they show you is the different stacked categories of the hurricanes, the trends for all hurricanes, and then the trends for major hurricanes, and they say that category 3 and above are major hurricanes. So before I get into the visual aspect of it, I quickly wanted to split them out by high and low categories, where 1 and 2 come in low and 3, 4, and 5 come in high. You can see the color coding right here. And I also created the same trend. So I used LM smoothing over here with a 5% confidence band, and I used the Poisson family to model the actual frequencies of the hurricane. And you can see that in both the cases, right, this is my 5% confidence band. It contains the inflection point. So let's say this line has a negative slope, but within my confidence band, I could have a line with absolute zero slope. And so you cannot say with absolute confidence that the hurricane trends are decreasing. Similarly, I don't know the model that they use, but with respect to my parameters, you can see that the trend is only minorly increasing but could also be decreasing. So this is a classic case of where people project false precision at the cost of accuracy. So their analysis, their lines are very precise. It does not give you the confidence band, but it's not actually accurate. It might just be less accurate. The second thing that how I created this chart is I was quickly prototyping. So this has been created in open source R. So TIBCO helps you write R scripts and use TIBCO Enterprise Runtime for R. But over here, I've called on to open source R, ggplot package, using RNR and rgraph. So I can very quickly show you my data function that does that. So within the data function, you can see the entire code for creating the plot. Before we move on from this stage, other two things that I also want to point out about this particular visual is that 5 categories, it's not ideal to put them on a stacked bar chart because it becomes very difficult for the human mind to perceive their particular patterns. So about 2 categories, you should put them on a stack chart. Everything else, you should probably move it to side by side. So I've split it out by facet, and I've also made it side by side. The other thing is granularity. So as you can see, their periods of showing the trends are a lot bigger than my interval periods. And that takes away some of the seasonality. Like you can see this as being very strongly seasonal almost, and over here there is no discernible pattern. So that's also a consideration to take into account when you're making the actual intervals as to how much you want to lose the granularities of each of the points. So we'll likely be doing another makeover of this graph soon. If you're interested in learning about creating R graphics in Spotfire, on the Tips and Tricks homepage, there's been R graphics in Spotfire articles published that you can refer to. On animating the graphics, we're coming up with another analysis. And finally, what we'll be covering in October 10, Dr. Spotfire featured session, is the impact of these climatic changes and hurricanes on the federal budget, and also how the damage implicates other spending and taking into account the future forecasts. So I hope to see you for that. Over to you, Michael.
Very good, DJ. Nice work, nice analysis. So we're going to now move into a detailed analysis of Hurricane Harvey, and Troy from Roost AI is going to be presenting that. If you haven't checked out exchange.ai, it's a wonderful marketplace for downloading Spotfire templates as a companion to our TIBCO community site. But let me now go across to Troy's screen. We can see your screen, Troy.
Are we live? Excellent. So we have the honor of actually being headquartered in the middle of all this flooding. being down in Houston. And so we're really excited to work with TIBCO to put some great data analysis together around the Harvey event. And what we looked at was after the hurricane. So we wanted to understand the impact that floodplains or the lack of floodplains classification has on Houston, and how we could use data to help identify other areas of Houston that should be under the floodplain flag. And that's a government zone that basically says that this area is, 50-year floodplain or 100-year floodplain. So we did a couple steps in order to run this analysis. Now, I'm also going to do something pretty exciting. I don't know if anyone on the call has tried this out, but I'm going to investigate this in Business Author. So I'm actually going to be running this through a browser. And the file that I'm looking at now, it's hosted on the TIBCO community on the geoanalytics page, which we'll talk about at the end. But you're more than welcome to click this open and click around when I'm clicking around in it. I've done a little bit of editing inside Business Author here, so I'm going to go over to tell you about the data that we loaded in, and then I'll describe the analysis. So the first data that we loaded in, it's 311 data. So in Houston, if you have any municipal issue, you call 311. It's different than 911 because 911 is for personal emergencies. Now, we loaded this data in post-Harvey. So we have about 6 days of data, and I made a tree map here so you can actually see the different categories. So I can grab one of these things, so I can click on flooding. So we still had people calling about flooding after Harvey. The neat thing about this data set, it actually has locations on the map, and then it also has a lot of great metadata around that particular event. So we know if it's closed, we have its XY location, and even how they reported it. So we can go through and actually investigate 311 issues in this regard. So you could look at particular categories of problems and see them on a map of Houston. Now, storm issues are an interesting way to track who actually was flooded and had significant debris. And what we wanted to do is cross-reference that with population and floodplain data. So that brings me to the next set of data we brought in. I'm going to go over to the census data. So we loaded in Houston census data, and basically census data is cut up into tracks. So I can come here and I can unmark this so you can see all the different tracks in Houston. I'm going to go ahead and change the color here. So I'm going to go to my shapefile. I'm going to change this to population. Okay, so now I have a little population density map of Houston. So you can see that this file has geometries, and I'm able to put that on the map, and then it has a lot of different information. I have the columns down here, so you have some population, so that's the total population. And the last census we ran was in 2010. So this is 2010 numbers, so we're going to use that as a proxy for the number of people living in these census tracts now. So you can see we have lots of data. Now, one thing we did is we intersected this shapefile of all these census tracts with the floodplains. And we were actually able to calculate this percent of neighborhood in a floodplain. So not only do we have all that census information on this data set, we also have what percent of that census tract area is in a floodplain. So I could grab this, which has high population and a high intersection with the floodplains, or I could go grab places that have low population and high intersection. So if you want to see where people live in Houston, I'll go grab the high density zones. That's basically where you have populations. This is where we have small populations. So you can see the small populations are more on the outskirts, which make a lot of sense. And then this stuff in the middle. So we had a lot of people in Houston who had flooding issues. So let's basically cross-reference this census tract data with the 311 data. And when we do that, we can actually calculate the number of calls per person. And that's what we've done in this analysis right here. So at first, we're just going to look at all of the 311 calls. So we can come down here and we can see the calls over time. You can see that there's a high volume September 1st, which is post-Harvey. it sort of fell off a little bit, but then we got back down to a nice regular rhythm of issues. In this top quadrant, I have 311 calls for each person in each of the different census tracts. So actually, each of these points is a different census tract. So I can click on a point, and you can see it highlights one census tract in the map. I can then look for places that had high exposure to the floodplain and a high population. You can see we have a general upward trend on these calls. Basically, places that weren't in a floodplain tended to have fewer calls per person, and places that were in a floodplain tend to have more calls per person. So that sort of fits in well with our theory that this floodplain is a good variable to look at in terms of understanding the 311 call model. So now what we want to do is actually we want to find anomalies. So we want to look for the places that had a lot of calls but weren't really exposed too much to a floodplain. So let's grab these guys up here. And you can see that predominantly on the eastern side of Houston, we're actually missing a lot of floodplains. And these people were greatly affected by Harvey. And we don't have a lot of floodplain coverage on the eastern side. And a big reason for that is when Tropical Storm Allison came through, which is the last time we updated the floodplains, it basically flooded the west side of Houston. So we got great coverage on floodplains on the west side of Houston, and we're lacking a lot of stuff on the east side. So we're hoping with this analysis that we can better identify areas that need floodplain coverage. And I definitely say anyone on the call, you can definitely download this data and look at this analysis yourself. So let's open up our 311 data, and we can actually go through and look for particular problems. So I'm going to go down to SR type. So I'm going to search for storm. I'm just going to look at storm debris issues. Now, all of my plots update. I can see the call volume for storm debris issues. I can then rerun this and look at these different categories. So previously we went through and we said anything with storm debris issues we're going to categorize, and you can see that, again, that general trend of things on the east side having poor coverage. You can see that this is just sort of a lot of different random places. And if I grab these, you'll see we have lots of areas that already have floodplains. So we can actually color by this. And then on my 311 map, I can come over here to the census map. I'm going to go ahead and switch the coloring around on this visualization. And I'm going to look at that classification that we just created on the exposure ratio. We can look at that. So all those blue areas are the ones that really need to have high calls, but they're considered low exposure. So these are the areas that need to have better floodplain coverage based on the 311 data as reported by people with storm debris and other flooding issues. I want to come back over to recovering after Harvey. So we also packed in some other neat visualizations in here. We come over to demographics. We can see a breakout of call issues by district, and then that population map. So we see all the different population labels in Houston. You can see that we have a lot of population along these bayous, and these actually tend to be high flooding areas. And we can grab different districts, if you're familiar with Houston, and actually see their call volume over time compared to everything else. You can also see where they land inside our exposure versus calls cross plot. And then lastly, if we want to see those individual events, we can actually go to this crisis mitigation, and we can see all the different places in Houston that had calls about storm damage. I'll zoom in. So you can see all these little arrows are different 311 calls. And I can come over here and actually filter to different 311 issues. So for instance, if we wanted to go back to everything and then look at evacuation, you can see where they are. this is a pretty cool trick because we've merged those two tables together, the census and the evacuations. You can just see the census areas that had the evacuation issues. And you can see, again, you get all this stuff over on that east side, which didn't have good floodplain coverage. I'm going to back up, bring everything back. And you can even look for something like flooding. And you can see, actually, we didn't have any flooding. Let's see where they are on the map. Yeah, the flooding events didn't have XY coordinates. That was the problem. So you can go through here and quickly see all the different issues that people called about. We thought this was a neat way to integrate two otherwise disparate data sets. So with that, we're really excited about it. We'd love for you to come check it out and hear what you do with this data set. You can grab it in two places. The first place you can grab it is on TIBCO Community, and this actually is a link out to a live web player version. And then you can also grab it off of exchange.ai. It's our public marketplace, and you can come and download it here, and along with a lot of other good developers, put up their analyses. And I also want to acknowledge the great developers who put this analysis together. Lucas Wood, who did all of the UI design and compiled the analysis, and Junia, who's one of our great data scientists. She actually did a lot of the calculations of spatial joins and floodplaining. So really fantastic analysis that they put together. So with that, I'll pass it back to you, Michael.
Fantastic! Really awesome job, Troy. I really like the way that you did that through the cloud, Spotfire cloud environment, and that folks can actually go to either of those locations, our community site or Troy's Exchange, and actually download the the application and play with it.
And following up on that, Michael, I would say, I mean, the cloud environment has really come a long way. Really snappy, and to be honest, it was something I haven't used in a while, and I did it for this. We were playing around with it in this analysis, and kudos to the development team for all the improvements they put into that.
Yeah, thank you very much, Troy. We're trying to get feature parity from thick client to thin client. It's a long-term goal, and we've made a lot of progress, and it's a very modern, convenient kind of user experience that's been provided there. And we do have thousands of people using our cloud application now, so yeah, it's getting quite a lot of activity from engineering. You might have to reshare it with me, Troy. I don't think I picked up the handoff that you gave to me in time.
I passed the ball. I passed the presenter
ball,
to you.
Michael.
I've got the ball, Peter. You can see my screen?
No, but you have the ball. You're not sharing your screen.
Okay. I just have to see something's happened. Something's gone wrong here, unfortunately. Let me jump that back out here and now share my screen from the menu system.
Yep, there you go. Starting up.
Yeah. Okay, so Peter, we're going to hand off to you for the final demo from today. Again, data from National Weather Service. If you can walk us through what you did first, and then show us how you did some of the configurations of that. This is the final demonstration today, so take it away, Peter. I'll hand you the ball.
All right, let me share my screen here. All right, can you see that screen? Okay.
Yep.
Perfect. Great. So what I'll be doing is, in many ways, a much simpler thing that you saw Troy show, and also DJ. This is basically just a portrayal of some data I got from the National Weather Service under National Atmospheric Administration. So basically, what they provide on the website is a set of data that you can download that has the precipitation on a grid. And so I'll get into the details of how I downloaded the data and how I prepared it, so forth, put it on this grid and everything. But just to cut to the chase here, the final result in Spotfire is this visualization over the southeastern part of Texas. Here's Houston, of course. The dark colors here show the larger amounts of precipitation. So the grid here is color-coded by the amount of precipitation per hour over a series of little grid cells here. This slider here actually accumulates the precipitation data over some time frame. So it's in this page, there's actually a couple of pages here, but in this page here, to look at the actual details of the precipitation, it's best to have a fairly narrow window of time. You just kind of roll this little time slice window through the time zones. What I've got is I've actually downloaded about 3 days worth of data in August when Harvey was approaching the Texas shoreline and Houston area, and you can see this data for those 3 days. And so the thing to realize about this graph is that the colors here are actually color-coded by, it's kind of a floating, a dynamic color. So the maximum and minimum are actually changing through time. So as you see a real band of the hurricane kind of approaching, the maximum kind of jumps up here. At the early part of this plot there, the maximum was like, 1.7. So this is actually a fairly small amount of precipitation. But the other plot on the next page I'll be showing in a second here does show a constant scale, so you can actually see things in the perspective of all that. But just to let you see it kind of a instant by instant of what the actual instantaneous bands are doing. So this really gives you a sense of, as Harvey is approaching the Texas coast here, you can actually see these individual bands of precipitation as they hit the coast. I hadn't quite appreciated that. You see these bands and these satellite images of the hurricane, and those actually do correspond to literally these bands of precipitation as they move in. And what occurred with Harvey, of course, as DJ showed, is that as it approached the coast here, we all saw in the news that it just kind of stalled there. So Harvey just kind of stalled, and with the counterclockwise motion, it just like drew all this warm air from the Gulf here into the land here. So as I go along here, the standards go like right over here, but the main brunt of the precipitation actually was taken up by the Houston area. So we're really exploring, you got this data set you can download from the National Weather Service, but you can really explore using Spotfire, just the dynamic visualizations let you just really see in great detail. Of course, I can zoom in on this if I want to, zoom in and study things in greater detail. I can actually do that. So it's really, Spotfire is just a really great way to understand what's really going on here and to really get a sense of what's going on. I'll be getting into the configuration of this as I go through here, but yeah, basically it's a way of really seeing visually what's going on with this event. So I slide this back here and jump to the next page. The next page actually uses a fixed scale, and what I'm going to do here is actually just move the right-hand side and look at the total accumulation. So the with the filter here in Spotfire, you can use it in a couple of different ways. One, you can look at the sort of instantaneous snapshot, and in that sense, it does make sense to use a kind of a floating scale here. But in this sense, I found it was quite useful to use a static scale that goes from 0 to, about 48 inches of rain. And as I move this upper boundary here, I can basically see as the hurricane kind of sweeps in and the individual bands apply. There you go. So I have this scale kind of turning kind of a purple color. So as the extreme amounts of precipitation arrive over time, well, it was just amazing. You really understand that the most time Harvey's eye spent was over here, but because of the geometry, here's the Gulf, here's all the warm water over the Gulf, all these individual bands of rain just accumulated over time to really hit this area of Houston very hard. So it was just a weird combination of the path of Harvey. It just stalled here. It just didn't move because of the high pressure system and so forth. And the direction of motion there just accumulated all the precipitation there. So that's kind of the end result. So I thought I'd go back and talk about how I put all this stuff together. So one of the key things about this visualization is that we have a grid. It's kind of hard to see, but if I zoom in here, the places where precipitation, the grid kind of drops away. So I'm actually only showing the grid in the time areas and time zones where, the locations where there actually is precipitation. So here there's a small amount of precipitation stored everywhere. It's kind of a cloudy color. But at the very beginning, there actually is no precipitation area. So one of the key things in making this visualization is to set it up in such a way that the grid itself actually goes away. So let me actually jump over to the where I got the data from. So the data is from the National Weather Service, part of NOAA, and you can go to this website and download individual files. There's actually a part of this website you can do this programmatically. So as part of this, I set up a loop to just go through, and I went through systematically and downloaded these files from the National Weather Service. If I look at the tables themselves, this is worth taking a little look at. So here's what I actually get from the National Weather Service. I get the, the year, the month, the day, the hour. So they're hourly files across a grid, and the grid is actually set up. This is HRAP, which I forget what it stands for, but it's an internal grid that they use. It's a stereographic polar projection, which they've described. But they give these X and Y coordinates in their own internal grid system. They also provide a latitude and longitude. So, and here's of course this is the actual precipitation value in inches for that hour for that grid cell in that grid cell area. You can plot this as directly in Spotfire as just a series of points. It doesn't show up as nicely, I think, as on this grid here. One point though is that the individual files are actually downloaded in a shapefile format, but they only contain point data. So I ended up just using the point data out of the download files. This HRAP grid, let me just jump over to this thing and I'll jump back to it. So the grid actually is documented pretty well in the by NOAA, by the National Weather Service. It's the Hydrological Rainfall Analysis Project, or HRAP. It's actually a fairly well-established, well-documented system of coordinates, but it is, it's a polar stereographic map projection, and they've got a certain polar setup. So you have to, to make these areas, you have to basically go in and kind of dig into the details of that to do this. So I ended up constructing my own grid using that documentation. So what I ended up getting at the end is using these HRAP X and Y coordinates, constructing an ID over here. Actually, I made a string version of this, which I then can use to match against the grid that I made with the tear, with R, basically. And R has a shapefile package, so you can actually read or write shapefiles freely into tear, into Spotfire, back and forth. So if you need to create a shapefile, it's very easy to do this. In this case, what I created was an entire grid here. So the grid you saw on the first page is a grid that I created to match this precipitation data set. So once I got the corners figured out, then it was pretty straightforward to create that grid. Now, the other part about this is the layer setup. So if I go into my map visualization here, normally you would say, oh, I'm going to make a map visualization in Spotfire. I'm going to bring in the shapefile as its own layer. it turns out that when you do that feature you saw where the colors go away when there's no data, that's easier to do with this configuration, this ultimate configuration. So what I have here is, if you look at the shapefile layers, there's of course the background layer, and this layer actually being shown here is it comes from that precipitation data table. That's the point-wise, hour-by-hour data table here. So the value of doing that is that when I apply the filtering, it's filtering and directly filtering out the this precipitation. Now, this is still point data, but it's appearing as a feature layer inside of Spotfire. So to get that to work, normally you would have the precipitation data appearing as a point-wise, but the feature layer is basically used typically for shapefiles. So the second part of this is the actual hookup of the geocoding. I'm getting a little bit of the weeds here, but essentially what you do is you use this geocoding feature to do a feature by, and you use that mapping to the key variable here. So this is kind of the secret sauce of how you do this. And you basically match it, you geocoding using that, that's the shapefile grid that's coming in here. So I'm using the geocoding from the grid itself to display this visualization. All right, so I guess this is a long-winded way of saying that, when you're done here, the advantage is that as you're basically filtering over the timestamps in that precipitation point data, and it's responding very, very rapidly. You're able to either look at the hour-by-hour data, or if I want to look at the accumulation in a certain time period, I can actually stretch this out and look at the accumulation. And then, of course, conversely, where there is no data for a certain time zone, the grid just drops away, just kind of melts away there. So there's that sort of unusual setup there using the, in the layer of the map thing, I'm using the actual point data. That's the way to get this to work. And that's basically the demo I got. So I guess I'll pass the ball. And,
yeah, that was awesome, Peter. And those subtle configurations of feature marker settings allows the casual power user, data scientist, whatever persona, to do those sophisticated mappings and get those results from those configurations, and the power of the engine to rapidly refresh across those large data sets as you use that slider is pretty impressive. So really proud of the work done by everybody today, showing off the true differentiation of our Spotfire Analytics products compared to anything else on the planet in terms of the engine itself, the configuration, both in the thick client as well as the cloud, the ability to create movies across time sequences. It's pretty much everything we showed today is not possible in any other software product. So great work, everybody. Let's go to Helene to wrap it up with the community. So,
Michael, I gave you the ball. So if you can,
you gave me the ball. Sorry.
too.
Sorry. Okay.
Yeah.
Okay. Okay. So yeah, we're going to wrap up now from Peter into Helene.
Great. Wonderful. So here we go. Can you all see my screen?
Yes.
Yes.
Good. Okay. So yes, let me wrap up with the community update. We're also getting close to our Q&A. So if you have questions, technical ones or otherwise, on the demos you saw, don't forget to submit them through the Q&A so we can answer them at the end of my section here. So we always have a few new people on this meetup. So I'd like to remind everyone or introduce everyone to the community. Very easy to find if you Google for TIBCO community, but the website is community.tibco.com. It's our platform for our users, and we've got about 10,000 active users at the moment. from all the different types of TIBCO software, but a lot of Spotfire users are on here. There are different ways to interact with the community. There is an answer section where you can ask questions and you get answers from either the TIBCO technical staff, our data science team, or your peers. And there's a very well used and populated wiki with a lot of how-to information. So this whole community is really to help you get the most out of our software. So a lot of tips and tricks there. Then we have the Exchange, where you can download templates that give you a quick start. I'll give you an example of that shortly. And the Ideas portal, where you have a direct connection with our product management team. If you have any suggestions to make our products better, that's where you can submit them. You can also vote on ideas from others that maybe have thought about similar things that you are passionate about as well. There's links to trials of other types of software that you may not be familiar with yet from TIBCO. And I think, the main thing to remember is that we post everything, for meetings such as this one on the community. So it's a great way for us to share information very quickly with you. So for this event, for example, besides being able to find the registration links, etc., all the videos will be posted, links to any of the data sets or demos that we've shown you that you can try yourself, links to the demo that Troy Ruth just showed you. So it will be easy to find things if you want to sort of try this on your own after the sessions. So for the TIBCO Analytics Meetup, we've got all our history of events on here with all the different topics we've shared with you in the past. All the videos are there as well as on YouTube, and on the Meetup we'll share that with you as well. So hopefully you can find it all easily. If not, please get in touch so we can further improve that. The wiki is I think, the most important part to start finding all the content that we have. We share things for people that are new to Spotfire, for the more advanced users, and then we also organize things on an industry basis. So there's lots of different ways to find it. I also always say that the search option is very good, either through search engines like Google or from the community directly. So that's a really good way to find things as well, because it searches across all the different aspects of the community, not just the wiki. A couple of new things on the wiki. DJ, who just presented, she actually put this page together about outliers, so the top 10 methods for outlier detection in Spotfire. As you all know, outliers are important to detect. They're usually associated with manufacturing, but they're actually important in all of the industries. DJ has been kind enough to sort of summarize the different ways in how you can detect them. So I encourage you to take a look at this page and let us know what you think. Community is very interactive, so you can make edits and provide feedback or ask questions, and we'll keep the content up to date. And here is one of the templates that I just mentioned that you can download from the Exchange. It's a new one that we recently published. Our team has worked on this. It's available for free, so it just gives you a quick start, in this case, to apply to quality control. We will probably demo this template in a future TIBCO Analytics Meetup as well, but feel free to take a look at it. There's a good description of it. These templates are all built for you to import your own data, so they're ready to use, and you can select relevant variables, you can compute control limits, so it's really good and ready to start your own analysis. DJ briefly mentioned Dr. Spotfire. Just wanted to remind you of that. There are many different ways in which you can submit questions to Dr. Spotfire. Our Dr. Spotfire team actually monitors the community quite closely to see what questions are being asked, and they pull up questions in this WebEx. It happens every 2 weeks to answer in the WebEx live the questions that are current on the community. So you may actually, when you submit a question on the community, be asked to join in the Dr. Spotfire session, so that the experts can answer your questions live. Well-attended session. Really recommend that you join in for it. It's always different every 2 weeks, because it's a direct response to the questions that our users have. And then we have two big events. Just to finalize my section, the final part of our global TIBCO Now tour is happening in San Diego on October 25 and 26th. So registration is open for that. And we also have our postponed but now reconfirmed Energy Forum on December 12 and 13 in Houston. So just wanted to remind you of those important events where there'll be lots of interesting sessions. You can learn about our products, so you'll see lots of customers present, and you can network with a lot of TIBCO and peers, Spotfire users from the community. With that, we have gotten to the end of this TIBCO Analytics Meetup. We're open for questions. The next meetup will be approximately in 2 months. We always announce that through the Spotfire online user group. While I was speaking, I think Peter and Michael have looked at the questions and chats that have come in. So anybody that has received any questions, please, Peter or Michael, ask them
so the question came in about how Peter and DJ created those movies, and I know they both described a little bit about that, but I wonder if DJ could just mention just the actual, I guess, configuration where you slid across the slices to get the movie. And while DJ is doing that, Troy or Peter, if you could bring up the site where we can download the community site where we can download the DXP files and so on, we could show that one more time. DJ?
Yes. So with respect to sliding over and creating the animation, on the tips and tricks page, you'll see write-up and documentation as soon as the scripts are cleared for public distribution. So you'll literally be able to grab them and create your own. But in order to describe it, there are 2 things that you would need. You would need an IronPython script that goes to your visualization, looks at that particular aspect of your visualization. So for example, I am in a map chart and I have my column which is featured by on the map chart. So I would iterate through my column variable one value at a time. So you go through all of them, and then at the end, you use a JavaScript script inside a text area that just calls the IronPython script over and over with time intervals. So think about it as IronPython doing the atomic modular work of moving the pointer from one thing in a column, one value in a column to the other value, and then JavaScript coming over and controlling the timing, pace, and loop of the whole interaction. So the start button that you saw was only a text button with IronPython and JavaScript embedded as text controls that control the whole thing. Now, this is just a base mechanism. There are a lot of ways of optimizing it. So for example, initially I was filtering over my timestamp column, but timestamp is date time, so it's a heavier data type to deal with. So instead, I went in and created another variable, which is just an index of accumulated timestamps. So the reason why I accumulated timestamp is that every timestamp showed only one shape. But I wanted to make sure that all the activity that is happening simultaneously gets projected at the same time. So based on the timestamps, for every 6 hours, I created a unique identifier ID variable, which is just an index going from 1 to how many rows in the column, I guess, 350 to 400 rows in the column. And it clubbed together similar timestamps. So I have about 270 unique values. And then I just filtered based on the timestamp and set all of my page controls and visualizations to work with the current page filtering, and that is how every time the index got increased, the timestamp changed and the layer that the projection on the map that you saw got changed. I also had a reset and a stop and a start. You can eventually make it loop forever by not stopping at maximum count. So in my script, I actually stopped at maximum count. If I just reset it, you would have infinite loop go on of the whole slide path and trajectory. So again, there will be a detailed write-up about this.
That's great, DJ. So that Python script that does the mechanics of moving through the layers, you'll make that available onto the community site, right?
Yeah, so I will make the two scripts, IMPython, that filters through each of the filter value that iterates to the filter values, the JavaScript, and how do you actually configure it? So if you have another column, where would you change the value of the column? What would be the inputs and outputs? I'll put up a detailed how-to wiki in likely the coming week.
That's terrific. I think for now, if you could put the scripts up, and then when you get a chance to put up the details. With respect to just showing, Troy, you gave a brief showing of the, the site where you can download your analyses from the community on TIBCO and the Exchange. Can somebody give Troy the ball to have him show that again as a way to kind of wrap up here? I think it's really useful. It's useful for people to be able to go grab those analysis files. Folks, the analysis files have the data in them. That would be, you can grab the data out of the analysis files. Guys, I'm on a public webinar here. So Troy, can you talk about what you've got here?
Yeah, so I'm on the TIBCO community site. Actually, a great way to find it is just to Google Spotfire Harvey. And the third link here, you just click on that, and it'll take you to this community site. And the data set that we have, you can just go ahead and click on this image, control click it, and it'll open up the live analysis in the cloud. And yeah, you can just download this as a DXP file straight from here. And then the other place you can grab it, if I Google Spotfire and Harvey again, you can grab it off of this, our Exchange AI Marketplace, and just download it straight this route. So we'd love to hear what you do with the data. And if you have any questions about this analysis or any others that you saw on the call, please reach out.
Yeah, that's terrific, Troy. That's great that we've got that up so quickly here that folks can actually get the DXP file, Spotfire file with the embedded data in it. And data's been cleaned up and so on, so you're kind of ready to go in terms of any analysis that you want to do on it. And as Troy mentioned, we'd love to see any other analyses of these data. So Troy, if you can just give the ball back to me, that'd be good. And I'll see if I can find any other questions that are coming in here. I guess a question for Troy. That seemed to be quite an interesting finding there of the issues on the east side of Houston regarding less floodplain creation, and it seems like the focus was on the area that got hit last time, which was on the west side of Houston. Seems like we sort of shut the door after the horses bolted, or whatever that analogy is. So we kind of fixed the issue that we had last time, and then we got a different issue this time. So I'm imagining that there's going to be a more systematic kind of review of Houston in this regard. Or have you seen any kind of follow-up from those issues that you've highlighted?
Yeah, so this is a big issue for Houston. It affects, obviously, the people who were flooded and who may be flooded in the future when we have further hurricane events. And this is something that's actively being looked at by Houston, and we're actually working with the Houston Chronicle to get this analysis up and help them with their journalism approach to investigating the issue, and hopefully working with some of the local government here to accelerate their findings and their needs.
Yeah, that's terrific. That Houston article, Troy, you got any time on when that might arrive?
You know, it's an interesting world working with journalism. You never know when it's going to come out.
Right.
But we're hopefully doing it soon. So we'll definitely share the link with the group because it'll have a nice Spotfire analysis associated with it.
Terrific. Yeah, that's terrific. Look, we're at the top of the hour, folks. This site here, TIBCO Analytics Meetup, is where you'll see the content from today be posted in this event here. You can see, you know, from last time we post the videos and, you know, any dashboards that are associated with these. So thanks. We really appreciate folks coming along to these approximately 1 every 2 month meetups from the data science team. And don't hesitate to, you know, send any of us an email to follow up on any of these things. I know several of you today, had some questions answered, but we'll be getting systematically through, you know, the rest of the questions. But yeah, don't hesitate to reach out to one of us and follow me on Twitter. I'll try and keep this site updated. I had a daily tweet come out last week on how to get registered and so on. Great job to the presenters, and look forward to seeing you all next time. We'll wrap it up now.